we want to find out the indefinite integral of the third root of x over x times quantity of square root of x plus x to the third root, cubic root, dx. And in a previous video of mine, I've proven Chebyshev's theorem regarding to indefinite integral, which claims that if we have an integral of this form, then only and only if one of these following three conditions is met, then it has an elementary antiderivative. So case number one, if gamma is an integer, or alpha plus 1 over beta is an integer, or alpha plus 1 over beta plus gamma is an integer, either of those, any one of those conditions is met, then we're fine. So first of all, maybe let's just rewrite our integral into this form. See if we can do that. So let's call it I. So I is equal to the integral of, first of all, I'm going to rewrite x to the cubic root as x to the power of third. 1/3. Then I'm going to perhaps extract square root of x. So here I have x outside here. So x times square root of x. That's x times x to the half. So that's x to the 3 over 2. Okay, I've extracted the square root of x. So I'm left with 1. Now I also have x cubic root of x, that is x to the 1/3. After extracting x to the half, I'm left with, so 1/3 minus half is minus 1 over 6. So x to the minus 1 over 6. Okay. Quantity dx. All good. Now I'm gonna further simplify. Now I equals combine this term and that term. So essentially I'll have to minus the index again. So 1/3 minus, because this term is on the bottom. So it's this index minus that index. So that's actually 2 over 6 minus 9 over 6 minus 7 over 6. So x to the minus 7 over 6, if I'm correct. So this term, but this whole term is on the bottom again. So actually I have 1 plus x to the minus 1 over 6 to the minus 1 dx. Now, this is in this form now. So let's see what's alpha in this case. Alpha is minus 7 over 6. Beta is minus 1 over 6. Gamma is minus 1, of course. Okay, let's see if one of these conditions is met. So if we have gamma is an integer, then we're fine. So we have enough confidence to move forward. We know that it definitely have an elementary antiderivative. Otherwise, there is no possible way that we can possibly tell. Okay, so just like the old method, I'm gonna let this term equal to t, just so we can simplify everything. So I'm gonna let x to the minus 1 over 6 equal t. Then x should equal to raise both sides to the power of minus 6. Just cancel out this exponent. So t to the minus 6. Then dx is minus 6 times t to the power of minus 7 dt. That's just a standard differentiation rule. Okay, so I have everything that I need. I'm going to rewrite the I into, first of all, x to the minus 7 over 6. So here, that implies x to the minus 7 over 6 is equal to raise both sides to the power of 7. So that becomes t to the 7. So x to the minus 7 over 6 is t to the 7. So t to the 7th times quantity 1 plus x to the minus, so that's my t. This is t plus t to the power of minus 1. Same thing. Times dx. dx is this. Minus 6 times minus 6. Minus 6 times t to the minus 7 dt. Simply just take out the coefficient. So I is equal to minus 6 integral of t to the 7th, t to the minus 7th. Just cancel each other out. Becomes 1. So 1 times what's remaining is this term. This term is simply 1 over 1 plus t, because it's to the power of minus 1 dt. Okay, this looks familiar. This is actually log. So I is equal to minus 6 to the times log of 1 plus t plus c, of course. Don't forget the constant here. So, of course, we have to replace t back with x. So t is equal to what? T is equal to x to the power of minus 1 over 6. Just replace it back. So I is equal to, I now is equal to minus 6 log of 1 plus x to the this plus c. Maybe we can further simplify that. That is equal to minus 6 times log of x to it here 1 plus x, because x 6th root, since it's negative exponent, therefore it's on the bottom. It's 1 over 6, so that's the 6th root. So maybe further simplify. But this is, I guess this is fine. Maybe somebody comes, maybe you come up with some solution with looks like 6 times log of whatever. Maybe x to the 6th root over x to the 6th root plus 1. Or maybe it's a different, but it's the same answer. Actually the same answer. You're not wrong. I'm not wrong either. So this is simply because if I just take the negative sign and bring the negative sign up to the power of this quantity. So negative 1 can be written as this bracket to the power of minus 1. To the power of minus 1 means it's reciprocal. So the reciprocal of this is actually that. Easily verifiable. This is fine too.